Let's talk about multiplying larger polynomials. The idea behind multiplying larger polynomials like binomials, trinomials, and maybe even polynomials of more than 3 terms is you want to distribute each term in one polynomial to each term in the other polynomial, and then you want to carefully combine like terms. An example of what a binomial times a trinomial might look like would be this. You have a binomial, which is a polynomial of 2 terms, right next to a trinomial. So when they're right next to one another and there's not an addition or subtraction sign, it means that they're multiplying. An example of a trinomial times another trinomial would look like this. We have 3 terms grouped together right next to another set of 3 terms grouped together. So we know then they mean us to multiply, not add or subtract, or they would have written that in between the parentheses. So let's look at these 2 examples using 2 different methods. First, using the box method, like we used when we were multiplying a binomial times another binomial. You set up a box. It's just this time our box has to be 2 by 3 instead of 2 by 2 to leave room for all the space for all the terms that we're going to get. So I put the trinomial at the top and the binomial on the side. We then start multiplying. So I have 3x times x squared would simply give me 3x cubed. I have 3x times negative 4x. That gives me negative 12x squared. And I have 3x times 1, so I would get 3x. On the bottom row, I have 2 times x squared, so I would get 2x squared when I multiply. I have 2 times negative 4x. That would just give me negative 8x. And 2 times 1 would be 2. Now for this box, it's just a little bit bigger than our other box, but we still look for like terms. So here I have x squared and another x squared term, but now I'm adding like terms, so I don't change the exponent, I just look for the ones that matched. I also have 2 terms that have x, so they're going to go together. So we bring over our answer. I have 3x cubed. Negative 12 plus 2 would be negative 10x squared. Again, don't change their exponent. And then negative 8 plus 3 would be negative 5x. And then we have a positive 2. You can write it if it helps. Just write the positive in the box right there. So our final answer would be 3x cubed minus 10x squared minus 5x plus 2. Now let's look at the other example. Our trinomial times our trinomial. We can just make a bigger box. So we have a 3 by 3 box this time. So your box size should match what you're multiplying. So I could put a term outside of each box on the top and on the bottom. On the side, I mean. So we have 2x squared minus 3x plus 1, and we have 4x squared minus x plus 3, and we can start multiplying. So I have 2x squared times 4x squared would give me 8x to the 4th, because while I'm multiplying them, I do need to add their exponents. I have 2x squared times negative 1x, so that would be negative 2x cubed. And I have 2x squared times 3 would be 6x squared. In my second row, I have negative 3x times 4x squared would be negative 12x cubed, because there's 2 x's and another x combined to give me 3 x's right there. I have negative 3x times negative 1x. That would give me a positive 3x squared. And I have a negative 3x times 3, so I would get negative 9x. And now I'm down to my final row, so I have 1 times 4x squared. I get 4x squared. 1 times negative x would still be negative x, and 1 times 3 would be my final box, which is a positive 3. Now we have to be really careful to look for our like terms here. So we have 2 terms that have x cubed, 3 terms have x squared, and 2 terms have x. So we're going to have to make sure we do our math correctly. So we have the first term is 8x to the 4th. It doesn't go with other terms that are in our box. And we have negative 12x cubed minus 2x cubed. So I get negative 14x cubed. At this stage, do not change the exponents. They just add together because they have the same ones. I have 6x squared, 3x squared, and 4x squared. So 6 plus 3 would be 9. 9 plus 4 would be 13x squared. I have negative 9x plus negative 1x. So I get negative 10x. And my final number would be 3. So that's a lot of terms to keep up with. It's nice to have a box to keep them organized, and it's good to see that the like terms usually will line up at a diagonal within your box. Now, let's look at these same examples using a slightly different method. So if I have 3x plus 2 times x squared minus 4x plus 1, the same example. Well, let's say that the box is not your favorite method. We can take the first term, 3x over here, and multiply it by each one of these, 3 over in this polynomial, and write them down. So 3x squared times x squared would give me 3x cubed. 3x squared times negative 4x would give me negative 12x squared, and 3x squared times 1, 3x times 1 would just be 3x. And then we take the 2 and we distribute it the same way, but then we can write down our terms underneath the ones they're going to add together with. So watch what I do. I have 2 times x squared. So 2x squared would go best right here underneath the term that already has x squared. Then I have 2 times negative 4x. So I'm going to put that right here underneath the term that already has x with it, because they're going to go together in just a second. So 2 times negative 4x was negative 8x, and 2 times 1 is 2. Then I need to add this all together. So I bring down 3x cubed, negative 12 plus 2 is negative 10x squared, 3 plus negative 8 is negative 5x, and 2. So if you look at your notes, you have the same answer, we just use a different method. Let's try the same method with this last example. So we have 2x squared times 4x squared minus x plus 3. So 2x times 4x squared would give me 8x to the 4th. 2x squared times negative x, that would give me negative 2x cubed, and 2x squared times 3 would give me 6x squared. So then, it might help if I use a different color, because these have a lot of terms involved. We have negative 3x times 4x squared. So that's going to give me negative 12x cubed. So let's put that underneath the x cubed I already have. Then I have negative 3x times negative x. So that would be positive 3x squared. So I'm going to put it underneath the x squared term I already have. And then negative 3x times 3 will give me negative 9x. Let's use another color for the next part. Whoops, I've already used purple. Let's say we have 1 now times each term in our trinomial. That's not a good marker. So 1 times 4x squared would give me 4x squared. So let's put it underneath all these terms that already have x squared. 1 times negative x is just negative x, and 1 times 3 would just be 3. And then we add all of our like terms together. So we can bring down 8x to the 4th. Negative 2 minus 12 is negative 14x cubed. 6 plus 3 is 9 plus 4 gives us 13x squared. Negative 9 plus negative 1 is negative 10x, and 3. So those are two different methods of doing the same multiplying, but these are larger polynomials. So you just have to make sure you distribute each term in one polynomial to each term in the other polynomial, and then make sure you're careful when you're combining like terms. When you're just adding and subtracting your like terms, your coefficients change, but your exponents do not. But while we're in the process of multiplying, you do need to add exponents. Notice here we have 2x squared times 4x squared. That gave us 8x to the fourth. So we do add the exponents when we are multiplying. But right here, when I have three terms I'm adding together that all have x squared, I just add the number out front. But I keep x squared like it is, because at that point, I'm just adding the terms together.